So what this table says, see previously you have studied about oxidizing agent tables. So what is the use of the table? Alcohols conversion into aldehydes, carboxylic acid, ketones we can say with using that oxidizing agent table. Okay. Now here this table is called reducing agent table. What is this? Reducing agent. It means we have aldehydes, ketones, carboxylic acids, esters, acid halides like this now. So these upon treating with lithium aluminium hydride, what is the name of this? Lithium aluminium hydride. So this is called as sodium borohydride. What is that? Sodium borohydride. So this is diborane B2H6. This one is metal H2. It means metal H2 means here also it like serves as a reducing agent. What it will do? Like all these are now acting as a reducing agent. Reducing agent what they will do? Reduces other compounds. Now what are our compounds here we have? Aldehydes and ketones, all these compounds are there. Upon treating with this reducing agent undergoes reduction. What they will do? Undergoes reduction. So for example, you take any aldehyde and upon treating with lithium aluminium hydride, with what I am treating? Lithium aluminium hydride. So that you are going to get an alcohol. See how many carbons are there? One alkyl group as it is. This carbonyl group carbon is there now, that converts into respect to alcohol. See what you do is lithium aluminium hydride, it means H minus it is giving. Okay, H minus and this carbonyl group carbon is electrophilic now, there this OH minus will attacks. So now what happens here? This oxygen will drag the pi bond towards itself. Now what happens? This H minus is adding means here, so it becomes RCH, this new H also coming, and this becomes O minus. Further hydrolysis gives you alcohol. So what is the final product you are getting? Alcohols. So what I am saying, aldehydes upon treating with lithium aluminium hydrides gets converted into alcohols. So aldehydes gives you primary alcohols. What alcohols? Primary. Because primary alcohols upon oxidation gives you aldehydes. So reverse of it. Next, ketones comes from secondary alcohols. Now ketones upon reduction gives you secondary alcohols. Perfect. R, C, R, H, OH like this. Is this clear? Okay. Like that carboxylic acid also, acid halides also, esters also gives you respect to alcoholic products. Fine up to here. Okay. Now if you see this lithium aluminium hydride can able to reduce all these compounds into respect to alcohols I am saying. But when it comes to sodium borohydride, it is only reducing like aldehydes and ketones and acid halides, but not carboxylic acid, but not esters. Okay, it means who is having more power, more reducing power? Lithium aluminium hydride. So who is stronger reducing agent you can say? Lithium aluminium hydride is a stronger reducing agent. Now NaBH4 is also a reducing agent, but relatively lesser. So this is weak reducing agent, this is a strong reducing agent, you can remember. Now you need to remember sodium borohydride can able to reduce what are the compounds? Aldehydes, ketones, acid halides. Once again, aldehydes, ketones, acid halide. Remember this, very useful. Okay. Now sodium borohydride is over. Next B2H6 is there. So B2H6 can reduce all of this compound except acid halides. What is that? Except acid halide. Now this metal hydrogenation is there now, can be done for all these compounds. Can be done for all these compounds. So next, here one more thing is there. Lithium aluminium hydride. See, what I am saying here is lithium aluminium hydride is there now, that will reduces all these compounds, it's fine. When I am treating with alkenes, there you have seen double bond O, carbonyl compounds. Here it is special concept, this is what? Like alkenes. When I am saying about alkenes, only this benzylic position alkene bond is there now, alkene double bond is there now, that will be converted into respect to alkane. It means remove pi bond, replace with two hydrogens, here one, here one. That is the product formed. It will not convert normal alkenes. Like normal alkene means wherever you are seeing like normal double bonds, that all won't converted into alkenes, but specifically which one I am saying, these benzylic positions are there now. Benzyl, see, this is phenyl ring, adjacent carbon double bond, can I say this is benzylic alkene? Yeah, this can be reduced to alkanes upon treating with what? So what is that? Only benzylic position alkenes can be reduced by lithium aluminium hydride. Normal alkenes, no reaction. So this is the thing you need to remember now. So now what is the use of this table means, see, there are some questions like this. Look at this question. What happening here? An ester, see, the given substrate, the starting material contains two functional groups. What are the two functional groups? One is ketone functional group and here ester functional group. Now, if you see the product, ester remained undisturbed as like that, but ketone converted into alcohol. So now what is a suitable reducing agent I can use? If I use lithium aluminium hydride, what happens? Both it will reduce as ketones as well as esters. Both will be converted into alcohol. But I don't want to disturb this. I want change only at here. So what is a suitable reagent I can use? Yes, sodium borohydride. So this is a selectively reducing ketones to alcohols but not esters. So best answer is NaBH4. Everyone clear? What is the use of the table? You got it from this? Yeah. So even this table, I mean this concept will be useful. Just you imagine you are doing some research and you want to convert one functional group to other. So here you can use this table now. What is a suitable reagent for conversion of carboxylic acids to some other product without disturbing other? You can use this table. Everyone got this? Yeah, perfect. Next one, here I just discussed about dibol H also in the previous class, if you remember. Okay, some people are laughing when I say dibol H. Okay, I don't know why. So now what is the use of this dibol H? Not now, in the previous class I am saying. It converts two things. Say something. No one remembered? Huh? Cyanides. Conversion of alkyl cyanides to aldehydes. Not only cyanides but also esters. Conversion of esters. Like this is ester functional group. Converts into aldehydes like RCOH. Like this you will get. So just remove this OR, replace with that hydrogen. So that is the use of dibol H. Now simply I can also make one question now. So this compound is now converting into this form. What is the reagent? What is the reagent I should use? Got the concept now? That's it. This dibol H, as like the reagents that we have seen in the previous slide, this is also a reducing agent. But this reducing agent selectively converts cyanides, esters to aldehydes. What I am saying? Converts cyanides, esters to aldehydes. Okay, so why you are specifically saying this means, see, if I use lithium aluminium hydride, esters with lithium aluminium hydride, what is the product formed? Tell me. Alcohol. Directly you will get the alcohol, respect to alcohol like this. But I don't want alcohol, I want only aldehyde. So what is a suitable reducing agent I can use? Dibol H. Got the concept? Now see, cyanides I have, alkyl cyanides I have. Now tell me, what will be the product formed upon treating with dibol H and upon treating with lithium aluminium hydride? Tell me what is your answer for this? Both of this? Here dibol H means aldehyde. So you write R C double bond O H. That's it. Next, what about this one? Lithium aluminium hydride, strong reducing agent. Na? So now here there is no oxygen. Na? So you should not say it is an alcohol. See here nitrogen is there. Respect to amine will be formed. What it will be formed? Amine. So R C amine means it should be sp3 hybridized like this. Okay, so to balance the nitrogen valency, carbon valency, I can put 2 hydrogen atoms. That's it. So what is the compound? RCH2NH2. Amine is produced with what? Lithium aluminum hydride. You got the difference between diboletes and lithium aluminum hydride? Yeah. So this is very important table. Mostly you can expect direct question with the help of that oxidizing table and this reduction table. That's it. Okay. If you want, you can write this application once again. Otherwise, we'll move forward. What? Now tell me, guys. See, reduction of aldehydes and ketones we are studying. See, what are the reduction methods we have studied till now? In the previous classes, we discussed about Clemmensen reduction, Wolff-Kishner reduction. What they will do, they will convert aldehydes ketones to respect to alkanes like hydrocarbons, I can say. Now, give one example. For example, here I am saying benzaldehyde is there. So now what is the product formed upon doing Clemmensen reduction or Wolff-Kishner reduction? Same thing you write as it is, like same number of carbons, everything is same. So what I told you, remove this oxygen and place hydrogens. How many hydrogens I should put? 2, that's it. So benzaldehyde upon Clemmensen reduction or Wolff-Kishner reduction gives you what? Toluene. Clear? Okay. So reduction to hydrocarbon, that can be done using Clemmensen and Wolff-Kishner. What is the reagent used in Clemmensen reduction, tell me? Zinc amalgam in acidic medium like HCl. Done. Next, Wolff-Kishner reduction, hydrazine NH2 KOH, basic medium upon heating condition. Okay, this is done. Now reduction to alcohols, we have many ways. What are those? Like carbonyl compounds can be treated with lithium aluminum hydride, sodium borohydride, B2H6, right? These are the things. Next, if you observe this table, you can see their physical properties. See, graphical representation showing that boiling point trends of N-butane, methoxyethane, it means it is ether, propanol, it means aldehyde, acetone is a ketone, propanol, alcohol. Given as like this, which is at the highest point you are seeing? Alcohol. So boiling points of, see, all of them are having almost nearest molecular weights. Nearest molecular weights అంటే దగ్గర molecular weights ఉన్నాయి. సో అందులో ఎవరికి ఎక్కువ బాయిలింగ్ పాయింట్ ఉన్నది చూడండి, ఆల్కహాల్స్ with the highest one. Okay, why alcohols means that OH group of alcohol can form hydrogen bonds. What they will form? If this is one alcohol, second alcohol, between them we may expect a hydrogen bond. So due to that hydrogen bond, molecular weight of that compound will be more. So we can say intermolecular hydrogen bonding. What is that? Inter. Okay, so intermolecular hydrogen bonding in alcohols makes them more boiling point. So after alcohols you have, see, ketones. What you have? Ketones. Alcohols, next ketones, next aldehydes, next ethers, least is alkanes. Okay, so remember, compounds with nearest molar masses or molecular weights, which compound will be highest molecular boiling point? Alcohol. Next one, ketone. Next, aldehydes, least alkanes. That's it. Okay, now arrange them based on their boiling points. 1, 2, 3, 4. Highest is 2. 2. Array, what is this 3? Write the structure properly. That CH3, CH3, between them O. What is this? It's an ether, not a ketone. Be present. Yeah. Next. 2, 1, 3, 4. That's it now. Next. What are the chemical properties? We have studied about nucleophilic addition today. Carbonyl compounds will show nucleophilic addition. How can you say that which is more reactive? More electron deficient, more reactive. If electron withdrawing group is present, it becomes more electron deficient, it will be more reactive. So now you can pass two statements. One is what? Electron withdrawing group increases rate of nucleophilic addition reactions. Electron releasing groups? Perfect. Next, reduction table we have got done. Oxidation table means there is nothing like table for aldehydes ketones. We have only for alcohols. Now look at here. Aldehydes upon oxidation. Tell me what happens upon oxidation. See, never do this carbon, never oxidizes, just this side. Hydrogen becomes OH, like R, CO, OH. So aldehydes upon oxidation gives you carboxylic acid. What they give? Carboxylic acid. Next. Now sir, what about ketones? Yeah. So ketones means what will be having like CO, like CH2, or like this we have some bigger chains like this now. Okay. So what we are doing? Oxidation. So where and how it happens? So ketones generally, do we have any direct attached hydrogen? No. It means ketone required stronger oxidizing condition. What they required? Strong oxidizing condition. So something like KMNO4 under heating condition, or concentrated nitric acid, like this we require. Now what it will do is, the cleavage of bond takes place. What I am saying? Cleavage. Where it takes place means this carbonyl group is there now, adjacent to that it will be breaking. Okay, when you are breaking this R, C, O, you have breaking this bond now, you insert OH group to that side. But దీని పరిస్థితి ఏంటి సార్ అని అంటే R, this carbon, that breaking carbon is there now, convert that into carboxylic acid form. Like this. So ketones, normal condition, no reaction. High temperatures or with strong oxidizing agents like KMNO4 or nitric acid, reaction takes place, product formed is carboxylic acid. How can we decide the product? Break the bond, convert them into carboxylic acids. Clear up to here? Okay. Now let us see. This is a ketone. I am saying you to treat this with KMNO4. With what? KMNO4. Now tell me what will be the product? Break the bond. Which side? Okay. Tell me which side? My side or that side? This side I should break? Remember, this side how many carbons are there? Count once. 1, 2, 3. 3 carbons. This side how many are there? Now remember, this rule is called Popoff's rule. What is that? Popoff's rule. So the rule says that you need to break in such a way that the carbonyl group carbon will goes with less numbers side, less number carbon side. It means this side how many you are seeing? 2. This side? 3. So where I should break? Because carbonyl group will goes with which one? Less number side. So this side it is going, so that you will get 1, 2, 3 propanoic acid. That side 1, 2, 3, that is also propanoic acid. 2 moles of propanoic acid will be produced. Clear everyone? Okay. One last question, you just tell me. Tell me fast. which side I should break? This side or this side? A side, B side? Yes, B side, because this is smaller. Now it becomes 1, 2, 3. Propanoic acid again. This one? 1, 2, 3, 4. 1, 2, 3, 4. Butanoic acid. Okay, done? Okay. చదువుకో